So we're going to be reviewing for Friday's test. It's the very first 100-point test. It's on Unit 0. And we're going to go over several sections of that test. As a matter of fact, I haven't given you this, but I will give you this description of the test. So questions 1 through 5 on the test will be classifying, okay? Classifying numbers. And you need to know these words, natural, whole, integer, rational, and irrational. They will not be provided. All right, so we need to memorize these words and what they mean because they will not be provided. All right, so if we just like the first 5 questions of the test, the first 3 questions of the class opener are those classifying numbers problems. So number 1, just because it's a negative sign, that doesn't make it an integer. Whenever you have a decimal or a fraction, what do we call that? Rational, right? Now, so again, you have to memorize the words. What are the first kind of numbers you learned? 1, 2, 3. And what are those called? Natural. Okay. You grew up a little and you learned about the number 0. What are those numbers called? Whole numbers. That's right. You grew up a little more, you realize that there's also negative numbers, which are integers. And we grew up a little bit more and we realize that not all numbers are nice, like 1, 2, 3, or like -3, -4, -5. But sometimes you have -3.5 or 1.5. When you have a decimal or a fraction, what do we call those? Rational numbers. And inside the word rational numbers, or inside the word rational is the word ratio, which means fraction, so that makes sense. And finally, when you have a decimal that's crazy, what do we call those? Irrational, right? And I'm talking about pi, a crazy decimal that's infinite and that doesn't repeat, doesn't have a pattern. So anyhow, we have these words that we need to memorize. I'm not going to give them to you. You need to know these words. You need to be able to spell them. You need to know what they mean to be able to classify them. So we said this one, because it's a decimal, it's rational. Okay. This one, the square root of 25. What's the square root of 25? The square root of 25. The square root of 25 is 5, and the number 5 is natural, right? Okay. Again, we want to be as specific as possible. Technically, if I would have said name all the groups that this belongs to, yeah, it's natural, it's whole, it's an integer, it's rational. But I want to be as specific as possible. The number 5, that is natural. Now, if I would have said the square root of 13, what would that be? Square root of 13? The square root of 13 would be irrational, okay? How about this one? 1/4. That is rational. 1/4 is a fraction. A fraction is a ratio. A ratio is inside the word rational, so that's a rational number. Okay, so, let's compare the following with the appropriate inequality symbol, less than, greater than, or equal to. So, this brings up the next part of our test. So, by the way, 5 questions are on classifying. The next 5 are on comparing numbers, okay? And on this description of the test, I give you tips on how to do that. When you compare 2 negative numbers, simply think about the number line. Whatever number's on the left is less, the one on the right is greater. Comparing fractions, if you have 2 fractions, get the same denominator, then you could compare the numerators. So that's what we have in this first situation here. We have 2 fractions, and I could convert the 3 to become 6. How could I do that? Multiplying by 2. So you multiply both by 2, and I'll get a new fraction. That'll be 2 over 6, which is the same thing as 1/3. It just looks different. It has a 6 now down here, just like this one does, which means now that we have a common denominator, we can compare numerators. So which one's bigger, the 1 or the 2? The 2, so I need to open up to the 2. So it's a less than symbol that's appropriate between the 1/6 and the 1/3. Okay, so whenever you have 2 fractions, the main idea or the best thing to do is to get a common denominator, then you could compare numerators. Yes, you could visualize if you wanted to. Like right here, it's pretty easy to visualize a chocolate bar. You chop it up into 6 pieces, and you could visualize how big that one piece is. As opposed to this chocolate bar, same exact chocolate bar, chopped up into 3 pieces, and that one piece will be bigger than this one piece. So this one's bigger. But visualization doesn't always work, especially when you have huge numbers, divisors to chop it up into. So right here, it's best to get a common denominator. I could change the 90 to become 900 by doing what? Multiplying by 10. So if I multiply by 10 up here, what do I end up with as a numerator? 470, right? 47 times 10 is 470. Now, when we compare 470 with 461, which one's bigger? The 470. One person knows, thank you. 470 is bigger, that's right. So the greater than symbol belongs right there. Number 6, we will have percents compared to fractions. Right there, let's convert the percent to a fraction by simply writing it over 100, because percent means per 100. So 41% really means 41 per 100. Now the other fraction has a denominator of 25, and I could convert that to 100 by simply multiplying both top and bottom by what? 4 right here and 4 up here, which means I'll get a 44 over 100. Now that I have the common denominator of 100 on both fractions, now I could compare the 41 with the 44. Which one's bigger?
44.
The 44. So there's a less than symbol. 41% is less than 11 over 25. And last but not least, number 7, the square root of 35 compared to 5.5. Let's compare apples with apples, oranges with oranges, decimals with decimals, right? So let's convert that square root of 35 to a decimal approximation. Now, if you were able to use calculators on tomorrow's test, you could just type in the square root of 35 and get a crazy irrational decimal, but you will be able to compare that irrational decimal with this nice decimal. So you're not able to use calculators on on Friday's test, I'm sorry. You're not able to use calculators on the test, so you have to do a decimal approximation in your head. So the square root of 35 is really close to the square root of what? 36. And the square root of 36 is really what? 6. So square root of 35 is a little bit less than the square root of 36. So the decimal approximation of the square root of 35 is going to be a little bit less than 6. So what would that be? It's about 5.9. So the question is, which one's bigger, the 5.9 or the 5.5? 5.9 is bigger. So it has to open up to that value. So going back to the description of the test, questions 6 through 11, 6, 7, 8, 9, 10, 11 are all about comparing. And let's move on to questions 12 through 15 on the test. Right there, they're going to ask us to give a decimal approximation to square roots that are irrational. Okay? And how do you do that? You simply create a perfect square number list, 4, 9, 16, 25, 6 times 6, 7 times 7, 8 times 8, and so on, and then use it to approximate the irrational value. So let's actually turn to some of these examples. So right here, we have 2 questions that say give a decimal approximation. So once again, the best way to do this is to actually make a list of perfect square numbers. So if you go 2 times 2, you get 4, 3 times 3, you get 9, 4 times 4, you get 16, and so on and so on. You make this list as long as you want. And then you could use this list to see where the number 50 will land. So 50 lands a little bit more than 49. It's between 49 and 64, but it's really close to 49. So what is the square root of 49? 7. What is a decimal approximation for the square root of 50? 7.1. It's a little bit more than 7, right? I mean, think about that. The square root of 49 is 7. The square root of 50 is a little bit more than the square root of 49, so it has to be a little bit more than 7, 7.1. Now, where would the square root of 72 land? It's definitely between 64 and 81. It's right here, between 64 and 81. Now, is 72 really close to 64? Is it really close to 81? No, it's pretty much between 64 and 81. So I need to think, what is the square root of 64? It's 8. What's the square root of 81? It's 9. So my square root of 72 is going to be pretty much perfectly in between 8 and 9. So that would be 8.5. So even though we only have 2 questions here on this class opener review for the test, there's actually more of these on the test, on the actual test. There's actually 4 of them. Questions 12, 13, 14, and 15 are all about giving a decimal approximation. Moving on to the next section, Questions 16, 17, 18, 19, 20, 21 are all about adding and subtracting integers. I always say think of money. Anything that has one minus sign or one negative sign, that means that you owe. Anything that's positive means that you have. Remember, minus negative, when you have them right next to each other, you have to change them to plus positive. So let's look at some examples. Now that's 6 questions out of the 30 that are on the test. So this is probably your biggest bang for your buck right here, adding and subtracting. Again, we think of money. -6 means I owe $6. +2 means I have $2. If I owe somebody $6 and I only have $2, I can't completely pay him off. I could give him the $2, but I want to tell him, hey, I still owe you $4. So -4 is my answer. Now number 11, again, I can't think of money yet until I change the minus negative to plus positive. And then I could say, okay, I owe $9. I only have $3. Could I completely pay them off? Absolutely not. I could give them the $3 and I'm still going to owe them how much? 6. Still owe them 6. Okay? So I guess I want you guys to recognize that when you see a plus sign, that doesn't mean that you're going to add. When you see a minus sign, it doesn't mean that you're going to subtract. It's more about, do you have or do you owe? And then once you understand that, you're going to know if you're going to be adding or subtracting in your head, and whether you owe money still or have money left over. Anyway, almost the final part of the test. Numbers 27, 20, and 28 are multiplying fractions. But before that, 22, 23, 24, 25, 26 is multiplying, dividing integers. Okay, so multiplying, dividing integers, we don't even have multiplying, dividing integers here. But that's just like -3 times -4 is +12, right? But I jumped straight to multiplying and dividing fractions. Because if you know how to multiply and divide fractions, you should know how to multiply and divide nice numbers. So on number 12, the best thing to do is to change the -16 and place it over 1 to make it look like a fraction. Now you could multiply 16 times 3, get a big number, 1 times 4, get 4, and then reduce that fraction. Or you could reduce first and then multiply later. So I have a 16 up on top and I have a 4 on the bottom. 16 over 4, you could reduce that by what? By 4. So if I reduce by 4, 16 divided by 4 is 4. 4 divided by 4 is 1. So just by reducing first, I don't even have fractions anymore. I really have a -4 over 1, that's just -4, times a -3 over 1, that's just -3. So what's -4 times -3? 12. So the answer is +12. Number 13, when I divide by a fraction, what do? Change it and then flip it. Change the sign, flip it. Now, the first one doesn't flip. The second one does. So change the division to multiplication and then flip the second fraction. Okay, we could reduce, right? The 3 up on top and the 9 on the bottom, we could reduce that by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. That does help us. And now let's just multiply top with the top. 7 times 1 is 7. And 3 times 2 is 6. And a negative times a negative is a positive. This is a good answer, 7, 6. Or you could actually divide 7 divided by 6. That'll go in one time. You'll have a remainder of 1 over the original divisor 6. 1 and 1/6 is also an acceptable answer. Either one's good for me on Friday's test. So going back to the description here. The multiplying, dividing integers, I didn't give any examples of those because I'm assuming that if you could do that with fractions, you could do that with regular integers. Now the final 2 questions are dealing with exponents. One has parentheses, one is without. Let's check that out. When you don't have parentheses, like right here, there's no parentheses around the -5. That means that the base is not truly -5. The base is really just 5, and your answer will have a negative in front of it. So what I always do is I like to circle the 5 squared. And what is 5 squared? 25. And what do I do with this negative sign in the front? Just put it in the front. So there's your answer. Negative 25.
Oh my God.
Now, number 15, it does have parentheses around it, which means that when I expand it, I'm going to have to write negative 2 in parentheses 5 times. Now, how about this? Even before giving the answer, will my answer be positive or will it be negative? It'll be negative, right? Because when you pair them up, a negative times a negative is a positive, a negative times a negative is a positive. You're going to have one odd one out, which takes it back to negative. Okay. Now, how would I actually do this? Because we're not going to be able to use calculators. I would pair them up. I would actually do what's negative 2 times negative 2? Oh, that's positive 4. And then I would do what's negative 2 times negative 2? That's also positive 4. And then we're going to just bring down that odd one out, the times negative 2. Let's actually do this. What is 4 times 4? 16. And then 16 times negative 2. What's negative 32. And that's about it, guys. This whole video will be uploaded, and this whole video is mirroring the test. All right? The same exact type of questions, if not exact questions, that you're going to see on the test. And we also have that description, that half sheet of paper that will be given to you, that'll give you even more, a better way to prepare for these different sections on the test.